Good morning to one and all. So today we are going to discuss about one of the most important part in our software engineering, languages and processor for requirement specifications. As you all know, what is the part of software engineering? Software engineering, the main part is development and maintenance. In the place of development, number of phases are there. The phases are analysis phase, design phase, implementation phase, test phase and maintenance phase. Out of these things, mainly we are going to discuss about languages and processor for requirement specification. This is in a part, this can take place in our analysis phase, that is in the first part. So what do you mean by languages and processor for requirement specification? What are the languages are used to consider requirement specifications? So that is the main part. In this place here, number of special purpose languages and processor have been developed to permit concise statements and automated analysis of requirement specification for software. Some specification languages are graphical in nature while others are textual. All these things are takes place either two forms, as I already mentioned, that automated or manually. Our purpose is to provide a brief introduction to requirement specification language and the processor. So there are number of languages are available in your software engineering. First one is PSL, PSA, problem statement language, corresponding problem statement analyzer. And then second one is requirement statement languages and corresponding REVS, requirement engineering validation systems. And then third one is SADT, structured analysis and design techniques. It is also called SA, structured analysis. And then fourth one, structured system analysis, it is SCA. And then last one, just all the above 5 languages can have its own characteristics. Some of them can take place manually, some of them can take place automatically, and some of them can take place graphical, or some of them can take place textual in nature. So for the above, first we are discussing about problem statement language. This was developed by Professor Daniel Tekro at the University of Michigan. The problem statement analyzer is the problem statement language processor. PSL and PSA were developed as component of IES-DOS project. PSL is based on general model of the system. This model describes a system and a set of objects where each object may have properties and each property may have property values. Object may be interconnected. The connections are called relationship. And then PSL system divided into 8 major aspects. They are system input-output flow, system structure, data derivation, system size and volume, system dynamics, system properties, and project management. So the explanation for the 8 cases, the system input-output flow aspects deals with the interaction between a system and its environment. System structure is concerned with hierarchical amount objects. What is the first one, second one, third one? This is a hierarchical architecture we mentioned in this place. Data structures. So it includes data structure aspects and all relationship that exist among the data used and or manipulated by the systems as seen by the users of the systems. Data derivations. The data derivation aspects of the system description specifies which data objects are involved in particular processes in the systems. Size and volume, system size. It is concerned with the size of the systems and those factors that influence the volume of processing required. Dynamic. A system can change the manner in which the system behaves over time. So that is the main part. Then project management aspects requires that the project related information as well as product informations be provided. This involves identification of the people involved, their responsibilities, schedules, cost estimation, etc. System properties. It specifies the properties of the system object. PSL is an automated analyzer for processing requirement stated in PSA and PSL. So the PSA system can provide a report in 4 categories: database modification reports, reference report, summary report, analysis report, structured report. These are a diagram in mention regarding PSA. So the internal part of this part, PSL, and then outer we have OS. The input is in a PSL and the output is in various kinds of reports are there. All these things are stored in our analyzer database. Command languages enter into the control unit. Database modification, whatever changes are considered, reports are stored in our database modification report. Reference report, whatever reference report, name list reports, it could be discussed. Formatted problem statements. There are 2 types of reports are there. Formatted problem statement report. Dictionary report provides a data dictionary. Summary report. Database summary report provides the project management information by listing the total number of objects of various types and how much has been said about these cases. And then RSL. This was developed by DRW, Defense and Space Systems to permit concise, unambiguous specification of requirements for real-time software systems. RSL, REVS are component of system software requirement. Engineering methodology. RSL has 4 primitive concepts: element, attributes, relationship, and structures. And then followed by these cases. So this is a diagram for requirement engineering validation systems. It has 3 components: translator and ASSM, and a set of automated tools are there. Translator, which is used to translate RSL, translator for RSL, and then centralized database abstraction system semantic models are there. And then corresponding outputs are there. These are the automated tools for processing information in ASL. And then third one, SADT, structured analysis and design technique. SADT incorporates a graphical language and a set of methods and management guidelines for using the language. SADT language is called the languages of structured analysis. Regarding this part, I already mentioned that what is the importance of SA. The SA language and the procedure for using it are similar to the engineering blueprint system used in a civil and mechanical engineering. So just like what we did earlier in our civil and mechanical blueprint, the same type of mechanisms are considered. And SADT model consists of an ordered set of SA diagram. Each diagram is drawn on a single page, and each diagram must contain 3 to 6 nodes plus interconnecting arcs. The 2 basic types of SA diagrams are the activity diagram and the data diagram. So the first 2 diagrams are activity diagram, the next 2 are data diagrams. There are 4 flows are the input, output, control section and the processor. How it could be takes place in this part. And then fourth one is structured system analysis, SSA. 2 similar version of SSA was described by Gane and Sarson and by D. Marco. SSA is used primarily in traditional data processing environment. SSAs incorporate database concepts. There are 4 basic features in SSA. Data flow diagram, as you all know, What do you mean by data flow diagram? Data dictionary, procedure logic representation, data store structuring techniques. Data flow diagram. SSA data flow diagrams are similar to SADT actigram, but they do not indicate mechanisms and control, and an additional notation is used to show data stores. Data dictionaries, that is in the place to define and record data elements, procedure logic representation such as decision table and structured English are used to specify algorithmic processing details. Procedure logic representations are used to precisely specify processing sequence in terms that are understandable to customers and developers. Important feature of SSA. Relational model is used to specify data flow and data stores. Relations are composed from the field of data records. The fields are called the domains of the relations. If record has n fields, the corresponding relation is called an n-tuple. And the last one, GIST. This was developed by USC Information Science Institute by R. Balser and colleagues. It is a text language based on relational model of objects and attributes. It is a specification is a formal description of valued behavior of systems. It consists of three parts: specification of object types and the relationship between these types. This determines a set of possible states. A specification of action and the demands which defines transition between possible states. A specification of constraints and state and transitions. So this is an overall condition for languages and the processor for requirement specification, especially in software engineering. So thanks for watching this video. Thank you very much.